In this problem, we have to find the duplicates between two sorted arrays and return them in an array of its own. Say we have an array 1 of 1, 3, 5, 8, and then an array 2 of 0, 2, 3, 8. We can clearly see that the repeated elements here are 3 and 8, and so that's what we will return here in this output. So the naive approach is to go in and look at every possible combination for every element. So um, we're going to look at 1, and then we're going to compare it with 0. We see that that doesn't match. Then we're going to go 1, compare it with 2, see that that doesn't match. And then so on down the list until you get to the end, and then you would move on to the next element of array 1, compare it with 0, compare it with 2, and compare it with 3. You see that it's a match. Push it onto this return array, and so on until you get to the end, which would be here. Same thing, you push to the array, and then you will return that array at the very end. So let's go ahead and code that up. So the first thing we're going to want is to declare a return array. We can call it return array and initialize it array1.for each. And then for every element, we're going to want to compare it with every element in array 2. So we're going to go ahead and make a inner for each with, we'll call element 2, if element equals element 2, then we know that it's a match, and we want to push, we can just say elem. It doesn't really matter which one, as long as we push it onto there. We are iterating through every element of the array 1, and then for each one of those we're going to be iterating through the entire list of array 2, and for every element of that we're going to compare it with this original element, and if that's the case, then we will push it onto the return array. And so let's just go ahead and console log this return array so that we can see what the output is. Let's go ahead and run this just to test. Cool. So we get 3 and 8. Now this solution is going to be very, very slow, and that's because for every element of one array, we're going through the entire list of the other array. So this is going to run in O of n squared time. We have to go back here and look at how could we maybe go through this array just one time and avoid comparing every element with every other element from the other array. So why don't you just take a moment, pause the video, and think of a good approach on how to do this. So a good solution would be to go through every element and put a little pointer there. So we can call the top pointer A and the bottom pointer B, and it's going to compare them, right? We start with B at 0 and A at 1. And because we know that it is a sorted array, then we know that if 1 was to match with an element, it would actually have to be to the right of this element here. So we're going to increase this pointer, and now we see that 1 is actually less than 2. So we can increase this pointer here and compare 2 and 3. And we continue this process until we find a match. So in this case, we found a match, and we go ahead and push it to the array, increase, increase, and then continue. So 5, 8, we know that 5 is going to be, because it's less than 8, that the what we're looking for is actually going to be to the right of 5. So we continue looking, and then boom, we got another match, push it to the array. So that's a pretty good solution. Let's go ahead and comment this out. Okay, so first thing we're going to need is a pointer, and we're going to want to create one for both arrays. So let's just call them A and B here, and we're initializing them to the 0 index. Okay, so then let's think through this one more time. We have a comparison of 1 and 0, and if B, so in this case B is less than A, so we're going to want to increase B. So Actually, we're going to want to put this in a while loop. So let's think about that. So when would this iteration end? Well, this iteration would end when we reach the end, right? But say that we have other elements here, right? So let's say we have a 9 there, and we get to here, and we compare 8 and 8. We push 8 to the array. We increase here. We're out of bounds. So we know that this 9 is not going to match with anything. So when either A or B hits the end, then we know that we are done, right? Then we're going to want to continue running this loop. As I mentioned before, in the first case, B is less than, so array 2 B is less than array 1 A. And then let's go ahead and think of the other cases. So if array 1A is smaller than array 2B, so in that case we are going to want to increase the A, right? And so let's just go ahead and put these increases in B++, and then else we know that if it hits this, then we already know that it's a match. So we're going to want to push to an array. So let's go up here and go ahead and declare that same return array, and we're going to push. It doesn't matter which one because we know that they are the same, right? And we're going to go ahead and want to increase both pointers, right? Just to show that one more time. So we have a match of 3 and 3, and we push 3 to the return array, and the next comparison we're going to want to make is 5 and 8. So that should do it. All we have to do once we hit the end is return the return array. Actually, let me console log that. Okay, let's run that again. Cool. So we're getting the same answer. So what would happen if we change, say, this 1 to a 0? We should get 0, 3, 8, right? So let's run that, see if that's what we get. And then let's say all of the elements are going to be in here. So this should be 2. We should get essentially the same arrays back. And sure enough, we do. Thanks for watching. See you in the next video.